Okay, I can tell the subnames are not being created correctly because it's creating the variable as an empty array. But when I look at this and then I look at the actual data files, here I notice there's a capital P in slow picks. That's the mistake I was making here. So now when I run this, it searches for and gives me the name of all the files that follow those criteria. So these are all the data files I want to preprocess. All right, so before moving on to the parameters file, where we're going to start specifying parameters of our data set, we're going to load the first data set. So we've done this, we've done number 3, we've done 2, 3, and 4. We just verified that the subnames are correct. Now we're going to go to the next section and we're going to run SI equals 1, which is here the first. This is specifying the for loop, which runs through all participants. So I'm going to again just run this top section. And as you can see here, it's going to start up EEGLAB. Many of the functions in this preprocessing pipeline come from EEGLAB, though there are plenty that do not. All right, so I'm going to specify just SI equals 1. So that's just going to mean the first iteration of the for loop. And then I'm going to run these next few lines, which is going to specify the current subname and then the in file name and out file name. And as you can see here, the in file name is 1001 slowpicks-1. So it looks like it's finding a appropriate file. So this is just a logic test to make sure that the input file exists and the output files do not exist. So if you have to rerun this again when you've already run things, it won't redo things. But we can skip that. So now here, this is where it's going to load up the data file. Now, there are several options here for loading data. Right now I have the brain vision function from EEGLAB uncommented because I'm using brain vision data. But if I were using Neuroscan CNT or Biosig or one of the other formats, I would just comment this one and then uncomment out that one. But I know that I'm using brain vision, so I'm just going to run these 2 lines. And as we can see here, it looks like it loaded the data. Now we should be able to go over here to my workspace, and I can see in the variable list that there is a variable called EEG. And when I open that up, I can see that I have data that is the shape 97 by 87,000. So it's loaded the data. So once I have done number 6 and loaded the first data set, I've opened the EEG structure in the MATLAB workspace. And now we're going to go to the parameters file because we need to specify some parameters. So I'm going to go back to my scripts here. Now I'm going to go to this parameters file. Now this parameters file is broken up into 3 sections. The first section is the steps. So these are the individual pre-processing steps that the pipeline is going to conduct on each data file. The second set, these are our parameters that are specific to the data set. So which channels are EEG, which ones are the mastoids, what do you want for baseline, etc., etc. And then this last section is cleaning parameters And most of these values I've either gotten from published studies or just developed over long term, just trying different values and seeing what works. So I would recommend not messing with any of these for now until you get a better handle on it. I typically don't change any of these things. This is typically the values I use. Okay, so what we want to do is fill out all these values, all these variables. So we're going to go to this EEG structure and figure it out. Before I do that, I guess I will explain the steps. So the preprocessing base script is going to run each of these steps in the order that they're presented. And so if you comment one out, for example, like this, it will not run that step. And again, if you wanted to add a step, you could add it in here. So I have several. These are some steps that you could put in that are not currently being used. If you wanted to rearrange them, you just have to copy and paste them in a different order because they will run them in this order. And each one of these names specifies a particular function or group of functions within the eegfix, the main script folder. But again, you shouldn't have to mess with those. All right, so we want to specify all these variables. So the first thing, actually this is not needed. I fixed that, so we need to specify what are the non-EEG channels. So we can go to this EEG variable, and again, this is EEGLAB format. It's a three-dimensional structure. And so we can go to eeg.channelocks, and this is all the channel information. And so basically what we do is go through this list of labels and write down any channel that we don't want in the final data set. So we're not going to want the iBlink channel or channels. If there's peripheral channels, there's another iBlink channel. So heart rate, skin conductance, we don't want those either. Now this is our typical data setup, so I already have them listed out. So you just want to list them out as a cell array. Again, being very careful that your spelling and capitalization is absolutely perfect. Then you want to specify, if you have them, both the vertical and horizontal iBlink channels. Again, the names, because this will be used for iBlink correction. The next two are for the mastoid channels. So in our lab, we typically re-reference all the channels to linked mastoids. And so I would just go in again to this channellock variable and find the channels that are the mastoids. So TP9 and TP10 for the brain vision. Those are mastoids. So again, I've already specified those, but you would specify the channel number in this instance. Then here we have the baseline start and end. So this is for ERP purposes, or actually it's really for baseline correction. So once it epochs, it will take the mean value in each epoch in this time window, and then subtract that from every data point to baseline correct. And that's right here, remove baseline. It's one of the steps. Okay, this is the epoching. So this is in seconds. So I'm doing -1 second to +2 seconds. And this is, again, from the events that I'm going to specify. And then here, this is a very important variable, triggers to epoch. So these are the events in the data that I'm going to want to create my ERPs around. So these are values that I will get from the data, most likely. So in this instance, in EEGLAB format, I would go to eeg.event. As you can see, it's a 1 by 75 structure. And so here, the EEG.event.type, these are the actual trigger numbers. So you see there's 75 triggers, and so most of them are 41s, 51s, 61s. For whatever reason, we're using PyCorder, and PyCorder, as a data collection machine, enters in an S and a space before each event. So there's a little bit of code I have to remove that. So once it's during preprocessing, that will be removed. So I just want to tell it that I want to collect all the events I just specified from 20 to 81 to catch everything. Alternatively, for our lab, we can go to data.collection for this specific experiment. So again, we're doing 114. Go into the archive, go into study codes, and then pick the file which specifies the task. So I think this will be, yeah, so this slow picks is what we're doing, and this will give us all the different triggers. So here, for slow clicks, we have 41 and 42 are the erotica, 51 and 52 are the neutral, and the 61 and 62 are the unpleasant. These are for different experiments, all these are. But this is where you can find, or at least you should be able to find, the actual triggers or what they should be. Okay, so back to this. Now that I've specified the triggers, this is going to specify the channel location file, and as I stated, we already have one in this preprocessing folder, so it's right here, and that again will cover most montages. So you just specify the location. Oh, I guess I should. Why does MATLAB do that? Okay, and then these two here. So oftentimes montages have a reference channel embedded in the montage, in the physical montage. So an electrode that all the other electrodes are referenced to. And so when you collect data, that's sort of what it references by default. And for this montage, it references CZ. Now, as I said earlier, we're going to re-reference to the linked mastoids. So we're going to want to reclaim this electrode. So when we're reclaiming the electrode, we need to specify both the name and the location. And so again, I already know this data set, so I know it's CZ, and I know this is the actual location. If you really needed to figure out if it was, for example, another channel, you might have to go into the EEGLAB. You could go into the chanlocks here, and again, here's all you basically be filling all these in. Now this is a data set that doesn't have any of the values in, but you could find another data set that has appropriate channel locations for that channel, and then you could just copy all those numbers and put it into your parameters file here, right here. All right, and then these last three are just specifying 3 other scripts within the preprocessing pipeline. So there's advars, cat code count, and custom script. So I'll talk about those each right now. So add vars, this is if you wanted to add a variable to the PTB format .mat file. So for example, an individual differences variable. So if you had a separate file, like a spreadsheet with each subject's questionnaire data, you could write a little script to have it enter that in here. This little bit of script is to create a variable called session. So we put in extra variables in the erp.stim structure. So this is session. So basically all this is doing is just looking to see what's the last character in the file name that it's currently running. If it's a 1, then make erp.stim.session1, and if it's a 2, make erp.stim.session2. So actually, I want this because we have 2 data files for each subject. So if we go, we see that we have slowpix-1, slowpix-2. And again, we can also see that in subnames. We can see that there's slowpix1, slowpix2. So as they're pre-processed, once they're done pre-processing, they're converted into PTB, it will create in the PTB file a new variable to specify whether it's a -1 or a -2, meaning session 1 or session 2. But you could put in any kind of script here to add in specific variables. And I've definitely created much larger scripts here when I've had to put in individual differences. So you can put that stuff in here. The next one is cat code count. So in the PTB, when we run the initial scripts in the PTB, we specify the triggers of interest into these variables called cat codes. And so this is, this top section is kind of stolen from the PTB. The format is very, very similar. And so basically it's specifying the different trial types. So this is actually for an emotion regulation task. So I'm going to have to change these. And the reason why we're doing this now is in the report that's created during pre-processing, it will create a variable for each of these cat codes and tell me how many trials are in each trial type. So how many epochs at the end of pre-processing do we have? And that's very important, which we'll discuss later. So I'm going to need to alter this document. And actually, I'm going to do it based on this. Again, the triggers from the study codes. So these are the ones that I care about. So I have pleasant, unpleasant, and neutral. So I'm going to need 6 cat codes. So here I have, so pleasant. Oh, so here we go. These are actually similar. So we're going to get rid of that. Oh, actually, we're going to need 12 cat codes because we're going to, oh, no, because we're doing it, I was going to say for pre and post, but we don't need to do that. So this is unpleasant 61 and 62. So this is erp.t type. This is where in PTB format the trial types, the triggers are stored in this variable erp.t type. So 61 and 62. So I want this to be unpleasant. So I'm saying either 61 or 62. So I put this or operand so it knows it could be either one of those trial types. So that's 61. So actually I'm only going to need 3 cat codes. Okay, so number 2 is going to be pleasant, and that's 41 or 42. And again, whenever you put in operands, you need a parentheses. "42. And then neutral is going to be 51 or 52. Okay, so now it will give me how many epochs for each of these categories of epoch types. And then the last one is custom script. And this, oh, definitely want to comment this out. This is again where you could add in, if you have some custom script, something custom you need to do to the data, you would put in that script here. And this could, because of the steps system in the parameters, so custom script right here, you could put that in at any stage. So if you wanted it to do something specific to the data at any stage, you just copy and paste it and put it wherever you want it. I don't have any custom script needs, so I just commented this out. All right, so now things should be ready to run. So here, so this is the loading. Here is the actual, the base script, or as a function, which will call all the different steps and do the pre-processing on this one data file. Then after it's done, it will, well, it can save the data file as a .set in EEGLAB format, or it will run this script, which will convert it to PTB and then save it in .mat format. And then it will, down here, it will integrate the subject report. So in the report for that individual subject, it will integrate it into the overall report across all subjects. And that's what it will do for one subject. So in theory, we should be able to run this on this one data file. Well, I guess actually I'll probably need to run this whole thing, the parameters, to make sure it's all the parameters are up to date. And then run this. And here we go. We can see that it's actually pre-processing. So I would recommend running it once, just running one data file like this in a sort of manual way, just to make sure all the parameters are correct. It's not erroring anywhere. And once you see this plot, you know it worked. Because what happens at the end, the last step of pre-processing, is it will create an EEG plot. So basically it will plot the first 5 epochs for all channels, the raw data after pre-processing, and it will basically take a screenshot of that and save it. And so when we go here, as you can see, there's a folder called EEG plot. You can go in here and we can very quickly look at the data to see, is it clean, is it not clean? And in a later at a later time I'll talk about going through those.